Let's have a look at how to troubleshoot problems which are preventing your computer from starting up. To effectively troubleshoot startup issues with your computer, I will first look at a typical startup process. This knowledge provides a foundational basis for identifying and resolving problems that may arise during startup. By examining each step of the startup sequence, this will help you troubleshoot where a problem may be. Starting the computer involves sending a start signal to the motherboard, usually accomplished by pressing the power button. However, other methods can also trigger this process, such as wake events from specific hardware components, such as a network card. The start signal is sent to the power supply. This essentially tells the power supply to start up. Once the power supply is ready to start sending power, it sends a power good signal to the computer. The power good signal informs the CPU that it's ready to boot up. For the CPU to start operations, it requires specific instructions located on a chip within the motherboard, typically the BIOS or UEFI chip. These instructions are then transferred to the memory for execution. Upon startup, the computer conducts a hardware check known as the Power On Self-Test, or POST. During this process, it tests various components to ensure they are functioning correctly. If POST detects any issues or everything is in order, it typically signals this through beeps from the PC speaker, or it may provide a message on the screen. In some cases, when there is a problem, you will get a series of beeps or a message to let you know what the problem is. However, if anything goes wrong before this process, the only thing that you may get is a black screen. To start with, let's look at how you would troubleshoot a black screen. During your IT career, switching on a computer and encountering a black screen issue is quite common. It can be challenging to resolve due to the lack of error messages or clear instructions of the problem's cause. One question you should ask is, has anything changed? A recent change may have caused the problem. In troubleshooting a black screen, inquire if any new hardware has been added, firmware updated, or if there have been any changes to the computer's setup. Sometimes adjustments in the BIOS or UEFI settings can render the computer unbootable. In some cases, resetting these settings to their default state may be necessary to resolve the issue. When troubleshooting a black screen, it's important to determine if a recent firmware update was applied and whether it was successful. If the update failed, a system with a dual chip design, where there are two BIOS or UEFI chips, can be advantageous. You can switch to the backup chip to start the computer. Modern computers typically have the BIOS chip soldered onto the motherboard, making it non-replaceable, which is a shift from older designs where the BIOS chip could be physically removed and replaced. If you encounter a firmware-related failure and don't have a dual-chip system, contacting the manufacturer for assistance would be the next step. One of the initial steps is to thoroughly check all the cables. Often, a loose connection is the simple cause of the problem. Ensure that every cable is securely and properly connected. Double-check each connection for a firm and complete fit to eliminate any potential loose or partially connected cables, which can often be the root cause of such issues. When troubleshooting a black screen, it's important to ensure cables are fully inserted. Sometimes a cable may seem connected, but isn't plugged in all the way, which can be deceptive. For cables with locking connectors, ensure they click into place and don't easily pull out. This indicates a secure connection. For cables without locks, make sure they are firmly pushed in. You will notice that when I pull on this cable, it comes out. Properly secured connections are crucial for ensuring all components communicate effectively and could be the simple fix needed for screen issues. You will notice that when I pull on this cable, it won't come out. This is plugged in correctly. Part of the troubleshooting process is to try a different port if you have one available. This includes trying other video cards if they are present. The video may simply be trying to transmit via a video card that is not connected. Troubleshooting is often about the process of elimination. Eventually, you should be able to work out what is working and then find out what is causing the problem. Checking cables is a quick process, but this may not solve the problem. You can also listen for any startup beeps. I will cover startup beeps in more detail later in the video. I will only briefly look at them here. On modern computers, one short beep means post checks have been completed and nothing was detected. The beep will sound something like this. One beep means the computer should be booting normally. If you have a black screen, the problem is most likely something to do with the monitor, the cabling, or the port on the computer. It is possible that it is the video card. However, if a detectable problem with the video card is found, you will generally hear a series of beeps which may sound something like this. Different computers emit varying beep sequences during post to indicate specific issues. If you encounter multiple beeps, it often points to either the video card or the memory. Typically, a continuous single beep in modern computers suggests a memory problem which prevents booting. In contrast, issues with the video card might allow the computer to boot, but you'll then encounter a black screen. Recognizing and interpreting these beep patterns can be key to diagnosing and resolving hardware problems. When providing phone support and encountering a customer reluctant to check their video cabling, a helpful approach is to suggest a connection reset. You could say, let's reset the connection by unplugging the cable and plugging it back in. This strategy is akin to the classic turn it off and on again method, but applied to cables. It encourages the customer to double-check connections without directly challenging their initial assertion that everything is correctly plugged in. When the computer fails to complete the post, indicated by a black screen and no beep sounds, it's advisable to check for any faulty components. A single manufacturing part can disrupt the post process, preventing the computer from starting. Thoroughly inspecting and testing each component can help identify the issue, enabling you to resolve the problem and get your computer running again. To identify which components might be causing your computer to fail to start, systematically remove one device at a time and attempt to boot up. For instance, if your computer has a network card and a graphics card, start by removing one of them. Although this demonstration doesn't use a power supply to assist visibility for the demonstration, this method is effective in real scenarios. By isolating each component, you can determine which one is responsible for the startup issue. I will start by removing the network card. After removing a component, you want to try and switch the computer back on. If the computer posts, it should make a beep sound or a series of beep noises. Keep in mind that it is possible on some computers to disable the startup beeps. When troubleshooting, don't assume anything is working. Consider it possible that anything could be the problem until you have been able to demonstrate that it is working. I will next remove the video card, which may seem counterintuitive as the absence of the card means no display output. However, this step is crucial for diagnosing an issue. If the computer completes post successfully, it will emit a beep or a series of beeps even without the video card. The absence of any beeps indicates a different problem. If removing the video card results in a series of beeps, this suggests the video card might be the cause of the issue. I will next remove the memory modules. This computer has two memory modules, and thus it is possible that one has failed. Troubleshooting is often a process of elimination. Focus on trying to work out what is working and what is not. It may seem strange to remove all the memory modules. The reason I would do this is that if I start the computer, most computers with no memory will emit a beeping noise or a very long beep. If you get this tends to indicate there's a problem with the memory modules, but the CPU is okay. However, not all computers will act the same way, so you can never assume. The last step I will perform is to reinstall a memory module in a different slot. If there is a problem with the memory slot, hopefully the computer will start up with the memory module in a different slot. Keep in mind that some motherboards will require a memory module to be in a certain memory slot in order for the computer to start up. So this does not prove what the problem is. However, if the computer starts posting, it tends to suggest the problem is with the memory slot. During troubleshooting, it is important to consider that a component might not be properly seated, meaning it's not making a good contact with the connector. Before concluding that a slot is damaged, ensure there's nothing obstructing the connection and that the component is correctly positioned in its slot. This step is crucial, as improper seating can often be mistaken for some serious hardware faults. Also, check for anything that is damaged, for example, burnt components. If the damage has happened recently, you may even be able to smell a component that has recently burnt. Sometimes it can be very hard to see the damage, and there are a lot of components on the motherboard that are very small. It's essential to inspect the power supply unit, as it might be partially functional. For instance, the fans might be operating without sending the power good signal to the motherboard. With most power supplies, the fan spins while the power supply is on. However, some power supplies conduct an initial self-test, causing the fans to spin briefly, then stop. Here the fans only start spinning when the unit requires cooling. Therefore, it is important not to make assumptions about power supply functionality without understanding the specific behaviors of your hardware. It is possible the computer is not starting up for other reasons. It could be the computer is not sending the signal to the power supply to start up, or the power button is broken or not connected. To test if this could be the case, you can test the computer with a known good power supply unit. In this example, the computer displays a black screen, so I will test it with a known functional power supply. The computer has a proprietary power supply, which means it is not the same shape as standard small form factor power supplies. Before ordering a new power supply, it's important to verify if the existing one is causing the problem, especially since I don't have an identical replacement unit available. This step is crucial to avoid unnecessary expenses and to pinpoint the exact issue. Fortunately, this computer, despite having a proprietary power supply, has standard power supply cables. This is beneficial as it allows for easier testing and replacement. However, it's not always the case, as some systems may have unique connectors necessitating the search for a specific power supply, or, in rare cases, power supply converting cables, which are also rare. To test if the power supply is damaged, I will first unplug the P1 cable from the motherboard. Once done, I will plug my known working power supply cable into the motherboard. With some computers, when the power supply is switched on, they will briefly spin up the fans. Notice that when I switch on this power supply, the fan spins up briefly. Since this was not happening with the other power supply, this is a good indicator that the power supply is the problem. This computer also has a P4 power connector that I missed, so I will switch off the computer, unplug this connector, and plug in the connector from my known working power supply. I will switch the power back on and press the computer's power button. The computer has started up, so it looks like the power supply is the problem. So I will order a replacement. If you are not able to test the power supply as I did, you can also look for other indicators. For example, this motherboard has an LED light. When I switch the power on, you will notice the light goes on to indicate the computer has gone into standby mode. Not all motherboards have this, but if you are lucky, there may be something to let you know power is going to the motherboard. The other option you have is to use a power supply tester. These devices allow you to test the power supply to see if it appears to be working correctly. The power supply tester will test the voltages from the power supply. I say appears to be working correctly because it only checks voltages and does not put the power supply under load. In this video, I will only check the main P1 connector, but you can also use it to check the P4 connector, PCI Express power connector, SATA, and Molex connectors. I have a different computer to test the power supply tester with. It uses a compatible ATX power supply. I will pull out the P1 connector from the motherboard and plug it into the power supply tester. Power supplies put out a number of different voltages, often referred to as rails. The power supply tester tests the voltages. CompTIA has removed the power supply tester from the exam objectives, but they would like you to know how it works. The voltage can be 5% plus or minus the standard to be considered compliant. For example, in the top middle, 11.9 is just below 12 volts, but not far enough out to be a problem. Bottom left is a little difficult to read, but it is 12.2 volts, again, not far enough out to be a problem. You will notice that 12V2 is flashing. This measures the voltage in the P4 or P8 connector that I did not plug in. This is to be expected. The power good is how many milliseconds it took for the power supply voltages to stabilize when it was switched on. This should be under 100 milliseconds, so it appears that this power supply is working correctly. Now let's have a look at what happens if you have a faulty CPU or firmware. If you think your CPU is faulty, the best option is to swap it with a known good CPU. If the CPU is having problems, you may get some beeps from the computer or you may not. It depends on the computer and what the problem with the CPU is. If replacing the CPU resolves the startup issue, it may not necessarily indicate a faulty CPU. It's advisable to check the BIOS or UEFI firmware for updates. Occasionally, updating the firmware can make it compatible with newer CPUs. This situation can be somewhat paradoxical, as you need a functioning CPU to update the firmware, but sometimes an update is required for the CPU to work. Once updated, an initially problematic CPU may become operational if the issue is related to firmware compatibility. If the firmware is a problem, the computer won't boot if it is damaged. The most common time this occurs is if a firmware update fails. Also check the jumpers on the motherboard. Motherboards will have a jumper on them that, when shorted, will clear the settings on the computer. Some motherboards will have 2 pins, while others will have 3. The third pin is usually a dummy that simply gives you somewhere to put the jumper when it is not in use. Resetting things may fix the problem. This may be referred to as CMOS in your manual. In the old days, settings were stored on a separate chip called the CMOS chip. Nowadays, the settings are stored in flash memory inside the chip. You will, however, still hear the term CMOS used. Different motherboards may act differently when these pins are shorted. Some will give you a black screen, which is interesting because that is the problem we are trying to fix. Simply removing the jumper or putting it in the correct position may fix the problem. If you're lucky, your computer may have firmware recovery. Check your manual and see what it supports and what the process is. If everything fails and you can't fix the firmware on the computer, you may need to contact the manufacturer in order to fix the problem. Computers on boot up will make a single beep to inform you that the computer passed post tests. Any other beeps and there is a problem. Keep in mind that on modern computers, it is possible to disable the single startup beep. A lot of computers are now shipping with this function disabled by default. However, other beeps will still sound when a problem is detected. CompTIA have provided a list of the original IBM PC beep codes for reference. I doubt you would get a question on a specific beep sequence in the exam, so this table is provided for reference only. As time passed, different BIOSes used different beep codes, and thus you can't assume the codes listed would be correct. It is always best to look up the beep codes for the computer you are using to see what they mean. On modern computers, generally speaking, if there is a problem with the video card, there will be one long beep followed by 2 or 3 short beeps. If there is a problem with the memory, there will be a long indefinite beep. Normally, when I hear multiple beeps in the computer, I will reseat the video card and the memory modules. These are the 2 most common problems that will cause startup beeps. I will next have a look at postcode readers. This is not included in the CompTIA exam objectives or documentation, but they are useful if nothing else in this video so far has helped you fix the problem. If you are only interested in studying for the exam, you can end the video here if you wish, and we will see you in the next video. For those still here, a postcode reader provides a hexadecimal code, essentially a code from 0 to 255. These codes are unique to the manufacturer. Some motherboards will have a postcode display built into them. If this is not the case, you can purchase one and plug it into your motherboard, if your motherboard supports it. Not all motherboards do. Some postcodes will have 2 sets of values. With these cards, one screen displays the current code, while the other screen displays the previous code. So don't get fooled into thinking these devices can display more than 256 different codes. To get a better understanding of how these codes work, I will use one to diagnose a problem on this computer. The computer has a faulty memory channel, thus any memory I put in two of the slots on the motherboard won't work. This PC postcard has 4 different connectors. You can see them on different ends of the card. If that is not enough, you will notice that there are holes in the card where you can plug in extra connectors if you have them and run leads to where you need them. To demonstrate a point, I will plug the card into the PCI Express slot. You will notice the light on the card will come on. Just another reminder, modern computers always have power running through them, even when they are off. Before installing cards like this, make sure the power is physically switched off. I will now press the power button, and you will notice that the card gets stuck on 00. What has happened is, this PC postcard is only supported on some motherboards using PCI Express. If you get a result like this, it is not supported. Since this computer has a memory channel that is not working, I will get an error beep. On this computer, notice that there is an Easy Debug LED section. The lights will indicate where the problem was detected. If you are having problems, have a look around the motherboard for any lights that come on, even if you don't have a post-LCD screen. You may have Easy Debug LEDs, which may help you work out what the problem is. With modern computers, the memory controller is in the CPU. A problem has been detected in the CPU, thus it is possible that the CPU is damaged, not the memory slots. Yet another reason not to jump to conclusions about where a problem may be. You probably missed it, but the PC postcard also has an Easy Debug LED section. But notice that the light for CPU has not activated like it was on the motherboard. The problem is none of this information is being sent to the card using the PCI Express slot, so I will use the card in a different connector to get it to work. For this particular motherboard, I will use the low pin count or LPC connector. In this case, the TPM connector is an LPC connector. The LPC bus is designed for low-speed devices to connect to the CPU. For example, the BIOS is often connected using LPC. Since TPM on this motherboard is using LPC, I can also use it to connect with other LPC devices like this postcard. I will now remove the card and put it in the TPM connector. The connector on the card is not keyed, and thus you can easily put it into the wrong header or in the wrong way. When putting it in, make sure you line it up with the first pin, which will be marked on the card and on the motherboard. If you put it in the wrong way or in the wrong header, you risk damaging the motherboard or the postcard. I will put the postcard LPC connector in the TPM header since they both use the same connector. I switched the computer off first, so I will now switch it back on. I will next press the power button to start the computer up. The code briefly changes before stopping on C5. It is hard to see, but the DRAM light is on. The motherboard reports it is the CPU, and the postcard reports it as DRAM. If I wait long enough, the code will change to 0D, and the light will change to PCI RST. When I consult the manual for the PCI card, the PCI RST light can be ignored, as it is not valid when the LPC connector is used. Thus, I need to focus on the C5 code. Manufacturers don't always release up-to-date postcodes. However, a quick internet search for the postcode C5 for this motherboard manufacturer shows a lot of people reporting that this problem is memory-related. Although the postcodes are good to have, they don't mean anything unless you can figure out what they mean. Hopefully, the manufacturer of your motherboard has released the postcodes. This is the main reason I treat them as a last resort. They can be really helpful, and at other times, if you can't work out what the code means, it is not helpful at all. Since it appears the problem is memory-related, I will remove one of the memory modules. I will next switch on the power and then press the power button. The computer will start up. You will notice that the postcard will change codes quite quickly. The debugging light will also change a lot. When using the postcard, wait until the code stabilizes. A lot of codes are simply telling you what is occurring. For example, testing a certain hardware. If the hardware test is successful, the next hardware item will be tested, which will change the code. Eventually, the code for this motherboard will change to 6.4, and the light HDD/PCH will light up. On my motherboard, I can see that Windows is booted. Thus, 6.4 for this motherboard means all the startup checks have been completed. In the real world, most of the time, troubleshooting involves testing with good parts to work out what is working and what is not. Don't assume anything is working. Test to see what works and what does not. As we saw in this video, one test showed that the CPU is the problem, while another showed that the memory was. But in this video, I never actually confirmed which it was. It was the CPU, by the way, in case you wanted to know. There is a pin damaged on the CPU, which is causing one of the memory channels in the memory modules not to work. Thus, I can only use 2 of the memory slots on this motherboard unless I replace the CPU. This video showed a number of techniques that can be used to find what may be causing a black screen. Start with a simple, easy test and work up to the more complicated ones if you can't find the problem. That concludes this video from IT Free Training. I hope you found this video informative, and until the next video from us, I would like to thank you for watching.